Good afternoon. My name's William Malik. I'm the Vice President for Infrastructure Strategies with Trend Micro, and we're here to talk about cloud operational excellence. In the course of this presentation, we're going to look at four items. First, why does it matter? It's cheap, it's throwaway, why not just do it? Well, it turns out it does matter, it can matter significantly. Then we're going to take a look at what metrics actually you should consider. And I'm going to take a moment to step on a soapbox to talk about what Frederick W. Taylor did and did not actually say regarding metrics. Then we're going to take a look at sustaining excellence, a non-trivial process, and we'll dip into topics such as the capability maturity model. And then we'll close with some next steps. So let me begin by sharing this presentation. So our topic is cloud operational excellence. And I'd like to begin with a story that talks about the value of process. This is from a paper that Howard Simon published back in 1962, and Herbert Simon, back to 1962. And he's using it to discuss the approaches to solving the problem of complexity. In this example, there are two people, both equally good watchmakers, both making equally complex and very fine watches. Tempus has a watch that's made of 1,000 parts, and he puts them together one at a time. If he's interrupted, he puts the thing down and it falls apart into its constituent pieces. Again, he has to start over. Hora, on the other hand, puts together a watch by making a set of parts into a subassembly. When he has 10 of those subassemblies, he puts them together into an assembly. And when he has 10 completed assemblies, he puts them together to make a watch. If he's interrupted, he puts down what he's working on and it falls apart. But notice that on the average, when Tempus has to put something down, he's losing 500 parts on the average, whereas Hora is losing 5. Remember, they're both making the same watch. It's a good watch, has an equivalent amount of complexity. But if you consider the possibility of interruption as taking place 0.1% of the time, the mathematics of it indicate that for every watch that Tempus completes, Hora will complete 4,000 watches. So that means you're going to get a lot more out of the process if you divide it up into useful, meaningful pieces and adhere to that. So that's really the bottom message, and I will hit this again at the end of the talk. Be careful about how you structure your workflow. Why bother to strive for operational excellence? Well, back in 1994, I was with Gartner and we acquired a company called Real Decisions. Real Decisions was an organization that had made its mark in the industry by keeping track of how efficient organizations were. So at its peak, they had over 300, let's call them global 2000 size firms subscribed. And these firms would submit to a process of careful examination of productivity and cost, looking at dozens of variables. The difference between the top performers and the bottom performers was a factor of 11. A factor of 11 in terms of the cost of delivering a unit of work. Now, the largest components of that difference turned out to be how many layers of management you had in your IT structure and what kind of terms you were able to negotiate for your hardware lease rates. When you look at cloud, that comes down to how effectively can you negotiate the price for the cloud you're using and how complex is your internal operational structure. But these comparisons are setting aside differences regarding to size and mission. So it's a like for like set of comparison. And note that of these organizations, top to bottom, every one of them spent significant money discovering how excellent they were. So we know that of these 300, there's better than an order of magnitude swing. What we don't know is of the other 100,000 who did not bother to perform a benchmark and probably aren't even at the caliber of those at the bottom of things. So An order of magnitude improvement awaits at least if you're already concerned about cost recovery and the efficiency of your operations. Why is it important to do this? No matter how much you outsource, there's still going to be something you're going to be responsible for. And I can't emphasize this point enough. So I'll just share a little personal health information to illustrate the point. I went to my doctor for my annual physical, and she said, Bill, I want you to lose weight. And I said, how do I do that? And she gave me two pieces of advice, which I'll share with you now. First, I should exercise more. And second, I should eat less. Being a skilled enterprise architect, I reviewed my core competencies and realized that fundamentally I'm able to eat less. Exercising more, however, is not in my groove swing. And so, as any reasonable architect would do, I outsourced it. I send a check for $75 to the health club every month. I haven't lost a damn pound. Those guys aren't doing their job. Haha. Well, the point is you can outsource, but you cannot lay off the responsibility for what it is that you are still producing. Always important to be able to measure the right thing and know what it is you're going for. So let's take a look at some reasonable metrics. And this is when I get a chance to ride my favorite hobby horse of all time. Frederick W. Taylor, the father of scientific management, said, and this was published in about 1923 or 1924, if you measure it, you'll manage it. And that was a warning. What he's telling people is be careful about what metrics you pick. To quote the old Firesign Theater, give them a light and they'll follow it anywhere. You put a metric in place and people are going to be comparing themselves against that. So make sure you've got the right ones. He never said, if you don't measure it, you can't manage it. We manage stuff without metrics all the time. Do you have children? The point is that that is a fallacy and misleading at best. So make sure you pick the right metrics. Pick the metrics that are relevant to your mission, relevant to your sector of the industry, relevant to what your competition is doing, relevant to what your customers and prospects expect. A good model for understanding how your metrics play into this is to overlay this on the competitive forces, the 5 forces chart that came out back in the 1980s. Anyway, what kind of metrics matter? Well, here are some candidates. I would not suggest you do all of these. In fact, I suggest that you see which of these would be relevant to what your customers are concerned about. In the case of the measurements of your service, you want to look at mean time between failure. That's how reliable is the system. Mean time to repair. That's how serviceable the system is. How available it is. If I click on the link, is it there? The metrics related to the efficiency with which you're using your IT resources. How's my throughput? How's my bandwidth? How's the latency? How's the response time? Those are internal measures. To a point, those matter. There was a wonderful research paper written in the 1970s called The Economic Value of Rapid Response Time, which showed that when response time drops below about a 1/2 second threshold, the experience of the user is as though they are in a conversation. When response time gets elongated beyond that, our minds wander. So we type in a question, nothing's happening. We take a look at our watch, we take a look at the coffee cup, the answer comes in, it's another interruption, and now we have to recover our train of thought. The impact on productivity of elongated response time is substantial. Even in the case of going from 1/2 second to 1 second, it can be considered a 4-fold decrease in productivity. So that may be a relevant metric if you are in an environment where time sensitivity matters. Think about checking out of an online shopping site, for instance. Uh, Strategic metrics. These are a much higher level and may bear more on the kind of mission statements your senior leadership team and your board would consider. And that is, how responsive are we to changing business conditions? That is, how agile are we? How quickly can we deploy new and needed functions. That's not the same as reliability or serviceability. This is talking about new business opportunities. How well are we engaging our customers? Think about SEO optimization. How able are we to reach prospects? What is the financial impact of this, good, bad, or indifferent? And how well does our solution fit in the space we're trying to address? You have to pick metrics that will help you guide those. And where you don't have a hard metric, pick a defensible soft metric and come up with a repeatable test that will tell you if you're, good, mediocre, or bad. It does not necessarily have to be quantified. In fact, one way to quickly lose all your credibility when speaking to senior leaders is to present a metric with 5 digits of precision about something that every one of those men and women will know is basically gut feel. Pick the right metrics, stick to them, and make sure they are reasonable. Let's take a specific example relevant to cloud providers. One metric that people would use is, how granular a time slice should I use when determining my time slice for pay for use, for changing the deployment, for responding to increases in demand. The interesting thing here is if you go too fine, the results are chaotic. I was working on the mainframe operating system in Poughkeepsie in the 1980s, and we improved our metrics for measuring computer performance, expecting that we would be getting better. And in fact, what we found is the measurements were getting fuzzier. And the fundamental reason is a computer is never 80% busy, right? Computer's binary. It's either working or it's not working. The best way you can interpret an 80% busy figure is to say 80% of the time when we looked, it was busy. And 20% of the time when we looked, it wasn't. If you look too often, you're going to see a scattergram. So you have to pull back. But on the other hand, if your granularity is too coarse, then it's going to be excessively unpredictable and irresponsive. The point is you need to establish a repeatable, meaningful baseline. And the gauges here on the right side of the chart are meant to talk about granularity and usefulness. Of those two gauges, at first blush, you might think that the bottom one, which is taken from an American car, is more information rich, and the top one is vague and general. But the reality is that the top one is more accurate and it tells you what you need to know. The bottom one is grossly inaccurate because we Americans are very sensitive about such things, and we don't want to pull away from the fuel station and have the needle immediately stop dropping. So when the gauge measures full, it's actually about 1.5 gallons above full. And so those first 25, 30, 40 miles that you drive, the needle doesn't budge. And that gives the fragile, tender American consumer a warm feeling that the car is extremely efficient. And of course, once you get below that, it starts dropping normally. It accelerates as you get in the last quarter. So although it looks like if you were in a 16-gallon tank car, that each one of those ticks is measuring a gallon, it's nowhere near that. The top gauge tells you what you need to know. It's better to be generally right than precisely wrong. So how do we sustain excellence? Now that we've figured out what the right metrics are, what do we need to do to ensure that our processes are as efficiently designed as possible to achieve and sustain and improve on those metrics? Well, there are a couple of different ways to do it. One that I happen to like, little secret, I actually helped write part of version 3 of COBIT. We're now on version 5. The control objectives for business and related technology describes about 34 processes that talk about all the things you do when you're managing a data center. Deliver and support 4 is business continuity and disaster recovery. Delivery and support 5 on the bottom there is managing information security. Now, this is the top level model. Within each of these processes, there are substantial details on what kinds of things have to happen to make that go. And it gets down to a very, very fine level of granularity. This is relevant because although it started out in the 1980s and early 90s as a model for how to run and most importantly, how to audit a data center, Nowadays, it's how to manage information technology, regardless of who owns it or where it is. You need to be able to govern these processes somehow, either directly or by remote control, which means you need to have repeatable metrics. Drilling a bit deeper into the COBIT model, we have a set of business needs. That's the high level requirements, what you're trying to do. And what we want to do is put in place a government structure that allows us to say, okay, what do we need to do at a granular level? How do we build to achieve that? And then as we run that, how do we know that we're achieving the results we want? Now, when you look at the individual job of any person working in an organization like this, it comes down to what we used to call HIPO, hierarchical input process output. And what we're talking about is the person in the center doing the process relies on inputs, information from colleagues, current data from various feeds, archival data. They're going to massage that information in some form and produce outputs that have to go somewhere. And in the course of doing that, they're going to provide data so that performance can be monitored. When a monitoring process discovers a gap, they discover missing inputs, they discover a flaw in the process, they discover outputs that don't meet the needs of the next person in the stage. Remember the old song by, was it Paul Simon, "One man's ceiling is another man's floor"? My outputs are your inputs. The whole process is eventually linked, and the result is value for customers or the absence of value for customers. So what you need to do, providing a cloud service or delivering packages or maintaining an apartment building, you want to know the responsibilities of each individual, and the responsibilities can be modeled in a COBIT style structure. The nice thing about this is it blows away any islands of information. It gets rid of people who hoard data. And it also allows you to analyze the process and eliminate redundant or unnecessary steps to streamline where appropriate. It may be that the downstream users of those outputs don't actually pay that much attention to them. I had a colleague at Gartner who used to sell for Xerox, and a client of his was producing this 140-page report every week. And so my colleague in sales recommended that they print it 6 up on 2 sides of a sheet of paper. So instead of a 140-page report, it came down to slightly more than 10 pages. And the customer said to the salesman, "Nobody's ever going to read this." And the salesman said, "Nobody reads it today." And it's like, you know what? We're going to microfilm. Anyway, the point is, you can improve the efficiency of a process if you make it explicit. And you can also handle problems that the process doesn't catch. Those are called process escapes. You want to hunt them down. You want to figure out what step in the model allowed this process to get entered. Remember, whenever there's a defect, there are 2 trouble tickets you would generate. One is to fix the defect, and the other one is to fix the process so that defect doesn't happen again. If you're not doing both, then you're stuck at what's called level 0 or level 1 of the capability maturity model. Now, this program came into business back in the 1980s. The US Department of Defense was spending an awful lot of money on software, and sometimes it was good and sometimes it was bad. And so they kicked off a study. They brought Carnegie Mellon University into it as well. People from IBM took a look, and I actually helped assist a guy who was doing that inside IBM in the early 80s. And it turned out the difference wasn't the educational background of the programmers. It wasn't the language in which they wrote. It wasn't the computer hardware in which they ran. It turned out that the critical difference between successful organizations that consistently wrote high quality code and those that failed to had to do with how they solved problems. And so in a nutshell, the capability maturity model comes down to 2 questions. Question 1 is, do we have clear, concise, current, well-documented procedures in place? Is there documentation? Can I look it up in the manual? If the answer is yes, you're at level 3 or above. If the answer is no, then the second question is, does anybody know what the hell is going on? If the answer is yes, you're at level 2. If the answer is no, you're level 1. Let me explain that. Level 1 is entirely reactive. You don't have enough time to do training. The next crisis is upon us. Down tools, kick off a task force. Everybody, you've been in places like this, when in trouble, when in doubt, run in circles, scream and shout. Well, over time, individuals become experts at something. And that's when you get to level 2, when you have an expert, somebody who can diagnose a problem. Here's the trap. Once an individual is recognized as an expert, then they become rewarded, they become lauded, they are sought out, they get a promotion, they get a nicer office, they get a close spot in the parking lot, they get the awards. You've made these people into heroes, and the problem with going from level 2 to level 3 is you have to tell the heroes they have to hang up their guns. We're going to fence the prairie. We're now turning into farmers. We're not hunter-gatherers anymore. And the best thing you can do as a hero is to train other people so they can do what you know how to do. The capability maturity model at the higher levels is talking about things like how to handle process escapes, how to deal with, true first failure problem diagnosis. How did this happen? Well, how did that happen? Well, how did something else happen? I mentioned this just a few moments ago. I know one organization where if a customer calls up to report a performance problem, the service desk opens 2 trouble tickets. One is to address the performance problem. The other one is to try to figure out how the customer saw that performance was degrading before anyone in IT knew that performance was degrading. Now think about it. If you're in a plane, think back, and you look out the window and see the engine has a problem, you will call a flight attendant and say, there seems to be a problem with engine number 1. But the big worry is, how come you saw it before the pilot saw it? In fact, shouldn't the pilot have seen whatever it was and taken action before the effect becomes visible to the end user entirely? That's the goal of an effective capability maturity model. And what we're trying to do here is drive down cost and sustain customer satisfaction. And there's a significant difference between the cost of a problem when it's found in the field and the cost of a problem when it's found during design. Now, this analysis was done in the 1980s as part of our work in support of the capability maturity model. And we're looking at the cost of a valid unique defect. For those of you with an IBM mainframe background, APAR stands for Authorized Program Analysis Report. If the bug is found during an architectural review, the cost of fixing it is measured in terms of tenths of a dollar, dimes. If you get to high level design, that same bug is going to cost you about $5 or $6. And this is the cost of the time of the people involved in the effort. Low level design, that's what we used to call pseudocode. I know this is waterfall, but every programmer does the same process, regardless of how the formal process is described. You design it, and then you code it, and then you test it, and then you ship it. Well, if it's found during system test, which is the phase where you have to essentially recreate a production-like environment, where you're worried about load, where you're worried about side effects, then the cost can get into the tens of thousands of dollars. Once the product ships, if somebody has to call the company to say this isn't working, the cost to IBM was $100,000. And that's a 1985 figure. It's only gotten worse. Yes, I know all about, we want to do rapid deployment, we want to do Scrum, we want to do Agile. I heard a wise guy say that DevOps is basically the Ricky Bobby of IT. They just want to go fast. Well, I think that's unfair to DevOps. I think they want to do good. Nobody goes into work hoping to screw up, okay? The fact is that teaching Silicon to behave is a non-trivial task. It's hard. It helps to have other people involved. That's why we spend the effort up front. It saves, I can spend 10 times as much effort on architecting as I spend on coding and still save money when it comes to defect reduction through that initial effort. Let's get specific. Suppose you're trying to audit cloud. Well, with the kinds of metrics most cloud vendors give you, it's like driving in a heavy fog. How do you validate the amount of energy savings? We take a lot on faith. What is total cost of ownership? Remember, the difference between CapEx and OpEx is a matter of time. If I buy something and it lasts for 7 years, what are the monthly payments of that same set of resources across 7 years? Now, remember that when you sign the multi-year agreement, the technology provider is going to be able to take advantage of Moore's law. You're not. One of the big problems we had with business continuity and disaster recovery was people would sign multi-year agreements and they'd get a 40% discount off list. And then in year 3 of the 5-year agreement, they had to increase capacity and they're buying essentially twice the going rate for the technology in the open market, and they're locked in. Looking at agility, the downside of agility is VM sprawl. How much can you really manage? You can stand up them in a second. You can take them down in a minute, but sometimes you don't bother to take them down at all, and you can end up exhausting resources on static, non-deployed, or unoperational environments. And how fast can you recover? If you have to, for audit purposes, go back and recreate an environment, how are you going to recreate the specific conditions that your operation was running, the specific levels of code, the specific contents of those input files at that time when the defect was suspected to have happened? Very complex process. Are you really doing that much logging? Are you really doing that much backup? Or do you just move forward? And how do you maintain availability and serviceability as you go forward? So the best practice here is only accept the claims you can prove. If you want to drive effectively in the fog, you're going to need to put a fog lamp in place. Fog lamps are non-trivial. This is the wiring diagram for the Helifog lamp scheme for the FJ Cruiser. There are a lot of pieces here. And if you get them wrong, they fall all over the floor and you have to start over from the beginning. In the US, we have FedRAMP compliance. IT governance is a global concern. Service level agreements or service level objectives may or may not be in favor in your particular environments, but in some way you are warrantying or guaranteeing performance against some set of metrics for your customers. And how do you handle vendor management? We used to call this third-party risk management. Now the vogue term is supply chain management. But the issue here is, who's giving me what? How do I know the quality of it? Have I harmonized my security and privacy policies with my vendors? Do they really tell me if there is a disruption or dislocation at the right time? Consider a service provider who's got people that have access to your environment. If they have to dismiss somebody for cause, what's the clock? How long do they have before they tell you that Joe is no longer allowed in the system? Is that something they handle completely on their own? Do you really want third parties having governance over who has access to your technology? You have to bear these in mind. I'm not saying it's always wrong, but it most certainly always is a potential issue. So how do we start? Well, it turns out that the requirements for governance in the cloud are fairly like the requirements for IT governments in general. We have various kinds of threats. We need to take care of them. External, internal, supply chain should be on the list as well. And you resolve that through a defense in-depth procedure. You don't just protect the endpoint. You don't just protect the network. You don't just protect a server that's identified as critical. You protect everything that you can. This, by the way, is the philosophy behind what we used to call network access control, and now goes by the uncomfortable moniker of zero trust. But the point is, you don't want to assume permissions just by virtue of the fact that a process or an individual happens to be in residence at the moment on a particular place in your network. The fact that they're there doesn't mean they have the right to access everything that's there. And various kinds of compliance, payment card compliance in the US, health information compliance, global data privacy regulations, and of course, internal audit constraints. So what do you need to do? Put in place a structure that preserves the trustworthiness of the environment by doing an effective job of blocking threats, stopping them, and rapidly remediating them, and make sure you are doing the right things for compliance. In other words, get your technology in place, have a good policy, and don't break the law. Now, for security automation, this is particularly important. We want to make sure that when you roll out those instances, they are coordinated with what's going on in your security environment. You don't want to stand up a cloud and then have a separate business process to stand up the appropriate security controls for the cloud. In fact, Every cloud instance is perfectly secure at the time of its creation. In the last 5 years, there have been precisely 2 instances where cloud providers have created a problem that led to a security breach. Don't blame the provider. The problem is the configurations are done wrong. Misconfiguration is the largest source of problems in cloud security. User error on the order of clicking on the wrong link, granting credentials or permissions to an individual who shouldn't have them. Those are both results of phishing, social engineering type attacks. But the point is, you cannot rely on a person to do something that's got a time critical job where there are over 100 variables and there's no template. Make sure you have automation in place that's good, and make sure you have some kind of scanning capability that can do that. Deployment automation, again, this is how quickly can we get stuff in there and pull it out when it's bad. Um, Reporting automation, you do not want to have to deal with 50,000 raw pieces of data. You want to have some sign of analysis and consolidation and results. Rather than a sea of data, you'd like a couple of bits of information. That's why middle-sized organizations are often turning to a security third-party managed service to handle security incidents. Again, you can outsource that, but it still has to have the right interfaces with your team to decide which corrective measures need to be applied in which order. Practice that. And orchestration, making sure everything's brought up at the same time. You don't want to put something out there, say, oh my God, we forgot to connect the brakes. No, 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 no. You can do better. You will do better. You need to understand your customers, your mission statement. You need to understand the impact of cloud on relevant enterprise performance. Again, pick the right metrics. Measure results, not activity. Define those critical performance indicators that will guide you towards achieving and exceeding those metrics. Make sure you instrument because you want repeatable, auditable, loggable stuff, and maintain a certain willingness to change in the light of new information, new technical capabilities, and new direction from the senior leadership team about the mission of the organization. I've included a set of a few references, the Herbert Simon story, also the mythical man month, which talks about why adding more people to a project tends to make it worse with regard to achieving deadlines. Please feel free to offer up any questions. I am here live to handle those. And at this time, I want to thank you very much for your time and attention, and we'll turn it over to questions. Have a good afternoon.